Okay, welcome at our midterm 1 review session, and thank you for joining me this evening. I did change the time because I thought maybe more students will join us since it's the evening time and we are more flexible in the evening. However, as I mentioned before, we do have lots of students with different time zone. That means I never know what's the best time is. But probably next week I will come back to the regular morning sessions. Okay, that means this is the midterm 1 week, midterm 1 review. We did cover chapter 1 and chapter 2, and that's the stuff for the test. You probably know by now, since I post some sample tests, and the sample exams are really close to the actual test. That's mean what we had. We did had in chapter 1 the basic concept of calculus, which are the limits. That's mean let's see. First, one more thing. On the front page I post like a short information about the test, and I state that the test, the midterm, will include 20 multiple choice questions only. Each question worth 5 points. The total is 100. And also, we are not allowed to use any formulas, no calculators, no electronics, nothing. You can only use the scratch paper and, of course, a pencil. Okay, that's the requirements. It's the same like for each quiz. Every week you're getting a short message on the weekly quiz, which is equivalent to the exam too, all of the exams. Okay, let's start. The basic concept of calculus, limits, and what I will start with that list. I did copy the list from the main website of math at PSU. They have this list, and we did, all of the instructors prepared the list together. That's the list of lots of different limits. It's 24, it's 45. Okay, that's what you can do. Some of them are extremely easy, some of them are a little bit challenged, but as a practice, I will really recommend to solve all of them. Okay, I will not probably solve them today, okay, but I will definitely recommend looking at the section 1.6, the section that the video that I solve the limits for you. All of the types are covered. That means the type with the square root, we know how to simplify. Some rational function, we also know how to simplify. Trigonometric, I also included. Okay, that means please make sure that you know how to solve almost all of them. And the good thing is you do have the answers. Okay, that means you can, I'm just looking at that red scratch. Okay, Andre, you can switch your video. If you can hear us, everybody should switch the video. I will switch mine soon. Okay, that's my recommendation. Also, if you like to narrow a little bit the type of the limits, I will recommend to go through all of the sample tests that I post on Canvas in week 4, because in each test contains a limit, quite like a short limit and important limits, which we always include in the test. Yeah, that means you can double check, and the solution is also provided for you. Okay, let's see what I have. That's, you probably remember from section 1.6, that's the special like formulas that it's worth to remember, because in order to simplify the rational expression, to simplify the limits, we will use some of the formulas. No question? It's all of this going to be posted somewhere specific. Oh, I don't understand all of this. You mean these formulas or the list of the limits? I don't really understand. all of the review that you okay, I am still a little bit confused. Whatever I'm saying now, okay, I am making a recording. That's when you always have the access to listen this again. And I also provide a slides for you that you can also watch just the slide, just the presentation. That means this is week 4. I hope by week 4 we know that, or unless the question is asking for something different. All of the review, or you saying the limits. Okay. Limits? No, the limits are there, and you have to work out, and you have the answers. As I said, all of the types, not exactly the same limits, but the types, the same concept are covered in section 1.6. The video is on Canvas. If you're really stuck with some of the limits, of course, I can solve it for you. But looking at section 1.6 and a little bit of trigonometric, which will be section 2.4, the limits with the trigonometric, all of the types, all of the concepts are covered. That means it's no point for me to solve it, because the learning curve will be better if you will solve it. Okay, that's the reason that I provide the list and I provide the answers. And I'm sure you can work it out. Okay, this will be important and helpful for your limits. Okay, let's see what else we have. In chapter 1, also the tool to compute a limit was the squeeze theorem. Hopefully you remember this. Also, some of the limits on that list, maybe they required this. That means when we have 3 functions, and that's the relation, f of x is less than g of x is less than h of x. And if we will look at the limits of the lower function and the higher function, okay, that we can see on the graph, the lower function f and the higher function h. And if both of them has the same limit at a, we can see as x approaches a, the limit is L. Okay? They kind of meet at the level, at the height L. That means everything what is between, in this case is g of x, also has a limit L. Okay? That means it's nice, especially if we're looking for the limit of the function. If we're looking at the limit of the function g of x, and we don't know what to do with this function, then we do have additional job, because we have to find function f and h. We have to squeeze it, the given function, between 2 new and known functions. And then we can solve the problem. And the typical example is the function with sine of x and cosine of x inside. That means, for example, let's try to find a limit of possibly x squared sine of 1 over x. Of course, at 0. Okay, that's when we can see that we don't really know, because sine of 1 over x is not defined at 0. That means if something is not defined, we're not really sure. We can't say 0. We can't say the function is completely undefined at 0. But then I see my function sine. I can definitely think about the squeeze theorem, because I can do this. Sine of, I will switch off my video, because then I see my whole screen. Sine of 1 over x, sine of any angle is between 1 and -1. Actually, I should ask you, what's the range of the sine function? Okay? That's when you can see what I did. It's so easy to create function f and h, -1 and 1. But something is missing. My original function is sine of 1 over x times another part, times x squared. That means I will multiply -1 times x squared. I will multiply the middle part by x squared, and I will multiply 1 by x squared. And now, as x goes to 0, negative x squared goes to 0. If x goes to 0, x squared goes to 0. That means if both of them goes to 0, the middle function is forced to approach 0. Of course, by the squeeze property. Okay? Everything what is between must have the same limit. That means this limit is 0. That means always when we see sine and cosine of something like weird, something that we don't feel uncomfortable, then it's worth to try the squeeze theorem. Of course, if both of these limits on the left and the right hand side, they are not the same, then we can't really use this theorem. Okay, please remember, if that 0 will be, if these two numbers will be not identical, then this property is not helpful. We have to find something else. Okay, let me now squeeze theorem. Actually, let's see if we have a limit that is good for the squeeze theorem. Actually, not really. Probably the limit that I provided. All of them are just the ratio, and we have to simplify. Another thing that you can maybe look quickly, scan it. Almost all of the limits are, if you do the direct substitution, they will give you 0 over 0. Okay, you remember this probably for the past 3 weeks. I was repeating this 0 over 0. We can even check limit as h goes to 0. If I the first one, if I substitute instead of h 0, I have 0 over 0. Square root of 1 minus 1, 0, h 0. Okay, that's mean all of them. And please remember, for 99%, 99.9%, the answer is not 0. Okay, that's mean please remember we have to work it out. The message for us is that this function on the top and on the bottom, numerator and denominator, at that 0 has a common factor, and we have to factor out, we have to find a common factor, cancel out, and then use the substitution again. Okay? Direct substitution again. And that's mean please remember, do not circle the answer 0 and go to the next problem, because that will be wrong. Occasionally we do have 0, but you really have to prove it. And what this means, first of all, you have to eliminate 0 from the denominator. We never divide by 0. And that means if you did eliminate the 0 from the denominator and you still have a quantity 0 on the top, then okay, the answer is 0. And that's mean please remember, we do have to have a reason to say that the answer is 0. Okay, never mind. If you will see limit like that, please remember, of course, you can remember the answer, the limit is 0, but what theorem we use the squeeze theorem. Okay, another thing that was really important in chapter 6 was the last section, in chapter 1. I was probably thinking about section 1.6. In chapter 1, the last section, 1.8. 1.8 was about the continuity. That means it's really important to understand when the function is continuous at the number a, and of course, function is continuous if the value is the same like the limit. That's the shortcut. We have to check a limit, we have to check the value, and check if they are equal to. Okay? Of course, at the number a must be in the domain. If the number a is in the domain, the value will be defined. And then the limit must exist. Having a value and the limit, we can compare. If they are the same, function is continuous function. Okay? Of course, it's easy to say, but let's see if we can solve this problem. Okay? For what value of b, the following function is continuous everywhere. Because we also remember, most of the functions are continuous on their domain. That means especially seeing the quadratic function, the third degree function, that's polynomials. They are nice and smooth curves. They are like continuous curve. B as a constant is also continuous function. The only number on the number line is 1. Okay? That we have to make sure that all of these quantities, all of these functions are meeting at the same height, the same level, the same limit. Okay? That means the limit from the left-hand side at 1 must be the same like the limit from the right-hand side at 1, and the value must be the same. That means this is the definition of continuity. Limit as x goes to 1 from the left-hand side, and of course I'm using this function, must be the same like a limit as x goes to 1 from the right-hand side, and is this one, 2x cubed minus 2ax plus 5. And the same like the value, but we can see at x, if x is exactly 1, this is the value. That means f of 1 is b. Okay, let's look at the limits. We can simply substitute. I don't see any denominator. I don't see 0 in the denominator. I'm substituting 1. 1 plus a, 2 minus 2a plus 5. And luckily, we have equation just with a as an unknown. I can solve for a. Actually, can you tell me what is the a value? We do have some participants. You can add 2a to both sides, and you can subtract 1. Oh, are you there? I think you're there. You can take a pencil and paper if you have it, or I don't know if you have the touch screen. Probably you can write on the screen too. Who can give me the answer? Because of course, I will solve a lot. It's 2. 3a is 6, a is 2. Okay. But now we can see, and of course, luckily, that the value 2 is not the option, because this is a. That's me now. Who can tell me what is the value b? Everything is almost given. Oh, 2/3. Interesting. I don't know exactly where the... Okay, this is just the value 2. Okay, that means now if we have the value, I mean, this is, I was gonna say a, this is just the value a. And if we have the value a, we can actually get more quantities. Let's see. It's not me, the noise. Who has the microphone on? Oh, maybe somebody left the room. No. Everybody has to mute the microphone. Okay. Hello, can you hear me? Because suddenly it's like a quiet. Oh, can you use the chat box and confirm that you can hear me? Okay, thank you, because you heard was some noise, which was from one of the students probably. Okay, good. Okay, yes, you are there, good. Okay, that's me. Now let's see. Okay, one more chance. Do you know what the value of b is? B is, let's look at this long line. What is b equal to? I can even like copy this. Yes, thank you. It's 3. Because b equals to f of 1, which is not really telling me much in terms of the value, and f of 1 is the value of the function, which for the continuous function must be the same like the limit from the left, and limit from the right. Knowing that a is 2, I can put 2 instead of a and compute my limits. But of course, 1 plus 2, it's 3. Okay, and if you compute the right-hand side, you will also get 3. Okay, that means the value b is equal to 3. Okay, we can kind of like looking at these equations. Okay, but of course the point on this slide is the limits. That means please remember, limit on the left, limit on the right, and the value must be the same. That's the concept for continuity. I have one more. Okay, almost the same question. For what values of the constant c will the function f have a limit as x approaches 2? Which means, okay, it's maybe not really continuous function. I mean, it is continuity, but I'm not asking directly, but I'm asking for the limit to exist at 2. Okay, That means the limit on the left-hand side at 2, we can see we do have again piecewise defined function. The limit on the left-hand side must be the same like the limit on the right-hand side. Okay? Actually, function is not defined at 2 at all. Okay, that we don't really have a value. Okay, but doesn't matter. Function will be not continuous, but still we may have a situation that the limit exists, because at value at 2 I can have situation like that. Okay, that's why I'm looking for this limit question mark. We may have discontinuity in this case because we can see no equal sign. 2 doesn't belong to any of these formulas. But what we're looking for this question mark. We want the left-hand side and the right-hand side meet at the same level as x approaches 2. Okay, that means let's try to find the limits. Limit as x goes to 2 from the left-hand side, and this is sine of c x minus 2 over x minus 2, and the limit must be the same like the limit on the right-hand side, x minus 2, absolute value of 2 minus x. Okay, that means this question contains a few concepts. That means first of all, for the limit to exist, both of the limits, they have to be the same. Okay, but now, okay, let's look at the left and the right-hand side. We do have a small problem, because when I substitute 2, I'm getting 0 over 0. And on the right-hand side, I'm also getting 0 over 0. Okay? That means I can't really say, I don't know, again, we good because the 0 is not an option. 0 will be not really the option unless I really get a 0. Okay, that means what I have to do, I have to, if you're getting in this type of equation, if you're getting 0 over 0 on one, do not combine these expressions. Focus on the left-hand side first, simplify, get the answer, and then focus on the right-hand side. That means possibly, do you know what's the answer on the left-hand side? What is this limit? Do you remember the property of sine of x over x as x is 0? This limit is, who can tell me this limit? If x is 0, sine of x over x. It's 1. Thank you very much. That's important. Thank you. Okay. Not only one person. Okay. That's what we can see. This doesn't mean that the x must be 0. The whole quantity, sine of the quantity, must be 0. And what I can see that my limit, x approaches 2. If I substitute 2, instead of x, I will have 2 minus 2, 0, and 2 minus 2. But what I also have, I have a coefficient c. That means I have c times x minus 2, which of course is giving me 0. But I can only use this property and say that this limit is 1 if I have exactly the same quantity in the denominator as the quantity of the sine, like an input of the sine function. That means what I'm missing, I am missing c. And you see what I did? I have c times x minus 2, and I have to see exactly the same quantity, c times x minus 2. But since I multiply denominator by c, I will also multiply numerator, because I can't just suddenly add a quantity. And now I can loop this, and I can say this is 1. This is sine of 0 over 0, and is identical 0. As we can see, c times x minus 2, c times x minus 2. That means, and of course, if x is 2, the whole quantity, the whole input is 0. Okay, that means the only thing what stayed outside the loop is c. That means this limit is simply c. Perfect. If I can manage to compute the limit on the right-hand side, I will have a c value, because then the limits are the same. Okay, on the right-hand side, I do have absolute value, and we remember what to do, I hope. They are also popular limits. That's mean what I have. Maybe I can factor out on the top, I will just factor out negative. Okay, that means I didn't really touch the absolute value yet, because I don't like x minus 2, 2 minus x is like opposite. That's why I'm making at least the same order. Factoring negative 1, I have 2 minus x instead of x minus 2. Okay, now let's focus on the denominator. In the denominator, I have 2 minus x absolute value. And we remember, if the absolute value is positive, like let's say, what's the absolute value of 5? Who can tell me what's the absolute value of 5? Of course, it's just 5. I don't even have to keep the absolute value. But now, what's the absolute value of negative 5? Of course, it's again 5. That means I'm not really allowed to put negative 5. That's wrong. But what I can do, I can copy this quantity like I did, and I can make it positive with additional negative. That's me knowing that my inside quantity is negative, putting negative in front, I am making correct answer. That's me now. I don't know the quantity 2 minus x. If this quantity is positive, as x approaches 2 from the right-hand side, I can simply ignore absolute value. But if this quantity 2 minus x is negative, as x approaches 2 from the right-hand side, I can copy this quantity and I can put extra negative, like I did for negative 5. That means, let's check. I can use different color. 2 from the right-hand side. If x is 2 from the right-hand side, like for example 2.1, what sign will have this expression 2 minus 2.1 or 2 minus 2.01? 2 minus 2.1 is positive or negative? It's negative, thank you. It's negative. That's the reason that I can copy this quantity. Yes, thank you for nice negative. Lily and Kais, I don't know exactly the names. Okay, that means the quantity 2 minus x is negative, and I'm making positive. Can you see this negative is the same like this one? Okay, and now I did everything what I could. Now I can just simplify. Actually, negative and negative will be gone, and 2 minus x and 2 minus x is gone. Okay, that means I can nicely simplify everything. C is 1. Am I right? Let me just double check. Yes. That means the C value, if the C value is 1, both of the limits on the left and the right are the same. Okay, that means that's how we can, that means I can tell you both of the limits, the sign, the trigonometric one and the absolute value one is important, because I can even create 2 different problems like that. Okay. What else? Okay, I do have this question. Let me check. But this question is nice, but also includes a little bit of chapter 2. But since it's the review, I think we can work it out. Okay, that means let's answer these questions, okay? Because they are like a little bit of concept question. They are not really, we don't have to compute, we have to just understand the concept of the limits, okay? Continuity, because of course we also have discontinuity, and I didn't ask for the type of discontinuity, but hopefully this question will ask and we will answer. And we also have a little bit of derivatives. We can see differential derivatives. Okay, but let's try. Question A. The limit of this function f of x, that's actually the graph of f of x. The limit of f of x exists at 2. That means, what do you think? Is this true or false? At 2, the limit exists. Is that true? Can you see what function does? This is 2. We remember, if we're talking about the limit, we're not looking false. Yes, thank you. Kaison, I don't know if I'm pronouncing Kaison. Maybe that's your first and the last name together. Kaison. Okay. Kishon. Oh my gosh. Kishon. Right? Not K. Okay. Kishon. Okay. Okay, Kishon, really good. Okay, let me just, this is false because the limit doesn't exist. What we can see, when we're looking at the limit, I mean, when we're trying to compute or find the limit, we're not looking exactly at the point. That's we're not looking at 2. We're looking what is happening on the left and on the right-hand side. And function, fortunately, or maybe unfortunately, does the same thing, right? Function goes to the positive infinity, but we remember, infinity is not a number. That means theoretically, I can answer that the limit at 2, it is positive infinity, but it's still correct to say that the limit is undefined. Okay, that's mean, please remember this. This is kind of like equivalent because the limit doesn't exist as a one finite number. That means, yes, this is the false statement. The limit doesn't exist at 2. Okay, what about at 4? The limit of the function exists at 4? Yes, yeah, okay. And actually, let me add the numbers. 1, 2, 3, 4. Can you tell me the limit at 4? What is the limit of the function f of x as x goes to 4? This is definitely true. Can you tell me? Because now it's a little bit, it's 3. Thank you. Because we're looking what function does, not the exact value. And the open dot is at the level 3, correct? Okay, now the limit of the function exists at 6. Oh, Kishon, okay, false. Okay, I exactly know the reason of your answer. Okay, that's what do you think? Is function continuous at 6? Can I, do you remember the video about continuity? Can I draw the function at 6 by one go? Or do I really have to take out the pen from the paper and come back? Or do we have continuity at 6? At 6, I'm looking at 6. Do we have continuity? Oh, no, yes, I think we do have continuity. It's nice, continuous fun. No, maybe not, I will not call this nice, because we do have a sharp corner, and thinking about chapter 2 and derivatives, we have the problem, but from the limit perspective and continuity, this is continuous function. That means as soon as it's continuous function, the limit exists. That means this is definitely true. The limit at 6, I believe it's 3. Okay? Because the function does the same thing from the left and from the right-hand side. Okay, that's correct. Okay, question D. Function f of x has a jump discontinuity at 4. Do you think this is jump discontinuity at 4? It's false because this is not jump. What type of discontinuity we have at 4? Do you remember? Only, yes, it's removable. That means it's not jump. It's not jump, it's removable discontinuity. Only one point is removed. Okay, question E. Function f of x has infinite discontinuity at 2. What do you think? Does function goes to the infinity? Or do we have infinity in the limits? We can look at, yes, correct. That means this is true. That's correct. That's correct. That's correct. Okay. Now, question F. Function f of x is continuous at 6. Oh, we did have similar question. Yes, of course it's true. Yes, because I was focusing, I see question C. For the limit, I kind of point the continuity. That means, of course, it's continuous function. True. At 6. Now, function f of x is differentiable at 4. What do you think? Do we have derivative at 4? Can you see 4? Differentiable. Okay, what the differentiable means? Derivative. Derivative is, another interpretation is the slope of the tangent. Okay, that means if I can find the slope of the tangent, that's fine. I have derivative. But in order to find the slope of the tangent, I have to have a tangent. That means if I have no point, how can I draw a tangent? How can I attach a tangent to that curve? That means no time. We have discontinuity. And we remember, as soon as the function is discontinuous, derivative doesn't exist. Okay, that means no discontinuity, no point, no tangent, no slope, no derivative. That means function is not differentiable. This is false. That's the false statement. I can write this way: derivative at 4 is undefined because we do not have a point. One point is somewhere else, but I'm not looking at that point. I'm looking at the function, the curve. Okay, now the next one. F of x, function f of x is differentiable at 6. What do you think now? Do we have derivative? Of course, it's false. Thank you. That was the original answer. Function is continuous at 6, but it's not differentiable because we do have a sharp corner. Right? Derivative at 6 is undefined. Okay. That's in please make sure that we understand what derivative means. Always please refer to the slope of the tangent. Okay, always slope of the tangent. If I will ask you this question is not on the list, but it just came to my mind. Can you answer this question? What is derivative of this function at 7? Do you think you can approximate f prime at 7? Okay, yes, correct. Okay, that means f prime at 7 is 0. Thank you very much. Okay, that means you do understand the derivatives. Because we can see, of course, I pick 7 because it's nice horizontal. Slope is 0, and slope means derivative at that point. Thank you. Okay, and maybe like at what other? 5? What's the derivative at 5? What's the value of the derivative at 5? Oh yeah, I probably don't see the difference, but it looks like 0 too, right? I can find 5 a little bit lower. Okay, that means please remember, if you see the graph and I'm asking for the derivative, always look for the slope of the tangent. Okay, and we do have question I and J. Okay, let's see if we can answer this one. We have to be really careful. Let's see if we understand. Because we didn't really talk about that, and probably I will not ask the last 2 questions because I didn't ask you for the limit. I mean, we did have a limit definition, which I will touch in a minute, but I didn't ask you for the limit of the derivative based on the graph. But let's see. What do you think? The question I, the limit of the derivative f prime of x exists at 4. Okay, that's what this means. This means this question is asking if the derivative on the left and the right hand side, because of course they don't want to check because we see the word limit, we're not really looking exactly at 4. We're just looking at the derivative of the function at 4 from the left and the right hand side, not exactly at 4. Okay, and as I just said a few seconds ago, that the derivative is the slope of the tangent. That means looking at the function f of x at 4 from the left and from the right hand side, which means that part and this one. Do you think we can draw a tangent line on the left and on the right hand side at 4? And the slope will be similar, which means the limit of the derivative will be similar, will be the same. Yes, yeah, because theoretically only one point is removed, but function does almost the same thing. That means drawing a tangent here and tangent here, we can see it's almost the same line. Of course, one point is removed, but it's the same line, the same slope. That means this is definitely a true statement. Because the tangent limit means we're looking on left and the right hand side. We're not looking at 4. But the slope of the tangent exists. tangent exists, slope exists, and they are the same. And now you should probably have no problem to answer the last question. The limit of the derivative, which means the slope of the tangent line to our function, exists at 6, which now, of course, is false. Now we have to draw a tangent line on the left and the right-hand side at 6, and we have to check if they have the same slope. No, of course, and we can see, yes, that's tangent line somewhere on the right-hand side, and that's the tangent line on the left-hand side. Totally opposite, positive slope, negative slope. That means this one is false. Okay, it's nice concept question. It's really nice to understand. But as I said, probably the last 2 questions are a little bit too challenging, but if you understand it, I'm so happy. I'm so happy that you understand this. It's good that you understand. And that's the reason that they put limit. Limit means that we're looking on both sides, not exactly at that point. Okay, let's move on. I will skip this question, or maybe you can tell me quickly the numbers. I just want the list of x for this function, the list of the x that the function is not differentiable. That means just the x coordinate. That means I can write it down and you can tell me. That means let's start from negative side. That means what will be the first value of x that function doesn't have derivative? Function is not different. -2. Thank you. I will write down. Okay, what's the next number? -1. Okay, because we do have discontinuity. -2, we have sharp corners. And we remember, one tangent line, another tangent line. They're not the same. This one, we have discontinuity. Okay, after -1, what is the next number? It's 1, another discontinuity. Derivative is undefined. Okay, after 1, 2, of course, another discontinuity. In this case, tangent exists, but we don't have tangent exactly at 2. Okay, and the last number? The last number is 3. Okay, that's mean again, just in case, you will definitely point out the numbers that function doesn't have derivative. And additional question, what is derivative at 4 of this function? Just testing you. If you're ready for your test, of course it's 0. Okay, thank you. Thank you, good, good. Okay. Okay, I do have connection between chapter 1 and chapter 2, continuity and derivatives, let me say this way, and we probably remember this theorem. If function f is differentiable at a, then it's always continuous. Okay, we remember that. That means if the derivative exists, we have to have continuity, always. But the converse is false. If function is continuous, then it's not differentiable. Okay, please remember that. Okay, and then, oh, I have another version. If f is, I think this is inverse, this one. I just inverted and put the negation. If f is not continuous at a, then of course, no derivative. Yeah, it's kind of like the same thing. Okay, that means this is true, that's false. False f. Excuse me. Okay. And then I have a few, but we kind of, based on the graphs, we answer the question. If you see a corner, if you see discontinuity or a vertical tangent, derivative is not defined at these points. No tangent, no slope, no derivative. This one actually has a tangent, but the vertical lines doesn't have a slope. Okay, rise over run. We don't have run, we can't divide by 0. And this is just the graphs. I'm attaching the graphs that we should know, the basic graphs, like absolute value of x, x squared, x cubed, 1 over x, absolute square root of x. This is half of the circle. We also did this one. And cube root of x, 1 over x squared, and x to the power of 2/3. Okay, just in case, like we have to answer calculus question, it's just much easier to know the graphs. Okay, and I think I have one question. Yes, this question. I mean, this one is nice, exam type question. Let's see if we can finalize everything what I said about this continuity and differentiability. Okay, which of the given function is or are not differentiable at 0? Right? And we have function f of x defined as an absolute value of x squared minus 1. We have function g of x, and we can see that's our fundamental function. Can you see this one? What do you think? Is this function continuous at 0? No. Differentiable at 0? It's not, because we do have the corner. That means this function, derivative at 0, is undefined. That means we can see how helpful it is to know the basic graphs. That means you have to promise me one more time. We have 1, 2, 6, 9. We have 9 fundamental graphs. Make sure that you know them. Okay, what about this function? Is this function continuous at, no, not continuous, differentiable. Is this function? Of course not. You know better my question than myself. No, derivative. Is this function has derivative at 0? Yes. Derivative at 0 is actually 0. What about this one? Yes. Derivative at 0 is actually 0 because we do have horizontal tangent. Oh yeah, we do have, do we have derivative at 0 for this function? Of course not, because we do have continuity. It's not even in the domain. What about the endpoint? Do we have derivative? No, we also, always at the endpoint, we will also say that the derivative is undefined. Because having the endpoint, like we kind of have like a sharp corner. Like I have like my endpoint. Yes, like how can I draw it? Like this is my endpoint. How can I draw a tangent line? Like that, like that, like that. Okay, that means please remember also at the endpoint, if we don't know what is going on the other side, no derivative. And okay, what about this one? This one is a little bit tricky, but do we have derivative at 0? At 0 is not a problem. Derivative at 0 is actually 0 because it's horizontal tangent. Okay, now if this is just this function, because we know that this is half of the circle, yes, but we don't really have the other half. That means my point -1 and 1 are the endpoints. That means I will also say that derivative is undefined at the endpoints. If I will have the other part of the circle, then I can draw my, oh, actually no, because if I will draw, okay, let's see, if I will draw the other half of the circle, what's the slope of this tangent? We do have tangent. I was just thinking that we have tangent, but what's the slope of this tangent? Do we have a slope of the vertical lines? No, that's mean no slope, no derivative. Okay, that's mean that's also, for some reason I thought that we do have tangent, which we have, but we have no slope. Okay, that means derivative is definitely undefined because we don't have really a slope at -1 and 1. Okay, and then, okay, this one, cube root of x, we have to be always also really careful because cube root of x is an inverse function of x cubed. Okay, and x cubed has a horizontal tangent at 0. Right? We can see horizontal tangent. Since this one is an inverse, has a vertical tangent. That means, what about this answer? Do we have derivative at 0? Do we have a, no, because slope of, oh, no. Slope of the tangent is undefined. We do have tangent, but it's vertical. Okay, that means derivative at 0 is undefined. And of course, this one, we do have discontinuity. That means no question, undefined. Okay, that means please, yes, make sure that we know these graphs. Okay, that means which function is not differentiable at 0? Definitely this one. Okay, we did answer that question. Let me not cover. Okay, we will investigate function f of x, but let's look at h of x. H of x has two parts. This function, x squared times sine of 1 over x, which is defined everywhere but not at 0, and at 0 the function has a value 2. Okay, that means now for the function, first of all, to be differentiable must be continuous function. And do you think the limit at 0 is exactly the same like the value 2? Because that's also one way. It's not. Do you remember what was that limit? I think I solved that limit. Okay, what is this limit at 0? Who remember? And what property I use? Oh, you do remember. It was 0. Was 0. And I used the squeeze theorem. Yes, thank you. I used the squeeze theorem. That means I don't really know exactly the graph, but at 0, the value is 2, we can see, and limit, whatever the function does, I don't know exactly how the function behaves. Let me just draw something, but the limit is 0. Okay, that we can see the limit is 0. We definitely have discontinuity. If we have discontinuity, function is not differentiable. That means definitely G and H. Okay, and now function f of x. Function f of x. What do you think? Does this function has derivative at 0 or not? It's not easy. I would say it's not easy to guess. What would be nice if we will get the graph of this function? Okay, that means function f of x is defined as an x absolute value of x squared minus 1. That means how can we get the graph? First of all, let's try to get, do you know the graph of x squared minus 1? Do we know the graph of x squared? It's just, yes, thank you, Teya, or yes, it's just parabola. And what minus 1 does? Minus 1, negative 1 is taking the whole parabola 1 unit down. Hopefully somebody is typing this. Okay. That means we have x squared minus 1. Okay, but now I have to get the graph of absolute value of this. And we remember, absolute value is always positive. That means whatever was positive above the x-axis will stay positive. Okay, positive, positive. Absolute, positive value, absolute value of positive is positive. But everything what is negative, absolute value of negative numbers will become positive. That means I have to do the reflection. And this one is no more on the graph. Okay, that we can get the graph of inside function, and whatever was negative, we can make the reflection and put on the positive side. Okay, that means this is nice graph of absolute value of x squared minus 1. Okay, that's y, that's x. And now we can see, does this function has derivative at 0? Yes, nice and smooth, and it's actually 0. That means this one is not my answer, okay, because this function has derivative at 0 and is horizontal tangent, and it's actually 0. Okay, slope is 0, and of course slope is derivative. Negative 1 and 1 has the corners, right? That means that's the problem, but not 0. Okay, that means, can you tell me which answer is correct? A, B, C, D, or E? Because I think I lost. Oh, B, let's check. Always make sure that you're, of course, selecting the correct one. G and H are my answers, correct. That means B is the good option. Okay. Okay. So I think if you practice limits, continuity, you will be good with chapter 1. Oh, I think we do have one more thing in chapter 1. Yes, we do have intermediate value theorem. I don't know if you remember from section 1.8. Okay, but let me talk about this because we never know. That means this was one more thing, which of course is related to the continuous function. That means what this property is telling us. Suppose that function f is continuous function on the closed interval from a to b. Okay, that's we do have blue curve. We can see one blue curve, another one. And let n be any number between f of a and f of b. That means any horizontal line, the pink line, we can see the horizontal, any horizontal line between f of a and f of b. Of course, f of a is the corresponding value for a, and the corresponding value for b, f of b. And where f of a is different than f of b, of course, because if they will be the same, that's a little bit different. Then there exists a number, okay, number c in that interval a and b, that the corresponding value is n. Okay, that's what this means. If I will take the continuous function, okay, maybe I can do. If I will take the continuous function, and if I will draw horizontal line, that means this horizontal line will intersect a function always at the point that the corresponding x value, c in this case, is between a and b, always. And what we have in mathematics, we have few theorems like that, and we call existence theorem, because what this is telling me is just proving that the number exists. And sometimes we don't even have to get the exact value c. I will only know that the value c exists and is between a and b. A and b will be given. Okay, that means this is like some property, and it is helpful sometimes to prove it. And I think I have a question that I can show you. Okay, and even if the function is like probably the polynomial more like the higher degree, we can even see drawing a horizontal line, I can even intersect my curve few times. Okay, and all of these numbers will fall in the, the corresponding x values will fall between a and b. That we can even have more than one. Okay, intermediate value theorem. And let's see if I have a question. Let's see, I have two questions. Okay, let's look at this one. This one is a little, we have to be really careful because that's a little bit for some x's. Okay, let's see if we can answer this question. Let function f of x be continuous from 5 to 10. The value at 5 is 1, the value at 10 is 4. Which one of the following statements must be true? Okay, that means I'm assuming, since they're telling me that the function is continuous from 5 to 10, the value for 5 is 1, value for 10 is 4. Okay, that means I can draw something, but let's make maybe something like that. It's continuous function. Okay, and now let's see which statement is true. F of 3, that we can see horizontal line 3, f of 3 will have the values, the corresponding x value will be for some x's between 5 and 10. Do you think this is correct? Yes, do you think it's correct? Because it is correct. Oh, but I will still, in this type of question, I will still try to investigate the option B, C, and D. That means this looks like a correct statement, because if I will get more correct values, then I will have a problem, because only one is correct statement. Okay, but this one looks good. My value 3 falls between 5 and 10. Okay, what about statement B? The horizontal line 3 will fall, the x value will fall between 1 and 4. That's messy, right? Because 1 and 4 are not even the x values. Okay, the value 7 will have the corresponding x between 5 and 10. I don't know because 7 is above 4 and I have no information about this and even this one. Okay, and let's check the last one. F of x is equal to 1, f of x is equal to 1 if and only if x is 5. Do you think this is true? I can also draw a horizontal line 1, even if 1 is my beginning. And we can see we do have value at 5, but we also have value at other values of C. Okay, that means it's not if and only if at 5. That's also false. Oh, I don't. That means it is, yeah, it's nice question. It's testing the intermediate value theorem, but only the first statement is correct. Okay, let's see, because I'm still in chapter 1, but chapter 2 was easy, right? Just derivatives. Okay, let's actually look at this question too. According to the intermediate value theorem, in which of the following intervals must in which of the following intervals must the function f of x have a 0? Okay, that's what we have. We do have a function, third degree polynomial. And what we want this value to have the value, this function to have a value 0. 0 means intersecting x-axis. Okay. That means if I will draw this function, I don't know exactly how the function looks like, but we can see that's 1, 0, that's another 0, that's another 0. Okay, of course, I don't know. But that's what they want. They want this function to be 0. This is 0. 0, of course, is the x-axis, 0. And they asking us, of course, we will use the intermediate value theorem. I can show you how we can use this. In which intervals? That means, I don't know, between -1, I will put between -1 and 0. We can see we have 1, 0 value. Between maybe 0 and 1. Between 0 and let's say this is 1, we do have another. Maybe between 1 and 2. And actually, I don't even have between 2 and 3. I can maybe write it down. As we can see, all of my blue dots, of course, this is not the right function. I'm just trying between -1 and 0, between 0 and 1, between 1 and 2, or 2 and 3. That's what we can do. Since the function is continuous function, okay, let me take the first interval from -1 to 0. I will get the value of the function from -1, and I will find the value of the function at 0. Okay, that means, let's see, let's substitute. -1. Now you have to watch my arithmetic because I will be substituting the numbers. Substituting -1, I have -1 cubed, -1 squared times -3, +2 plus 3. This one is +1. You can double check. And this one is 3. Okay. That means what I'm getting. I got positive number 1 and positive greater than 0 and greater than 0. Right? That means if I got 2 positive numbers, I will remove this because I would like to show you. Because what I'm looking for, I am looking for one number positive, one number negative. That means for -1, the value is 1. Okay, the value is 1. For 0, the value is 3. Okay, but you can see we do have both values above the x-axis. If function is continuous, I can simply connect the function like that, and I can maybe draw. That means if both of them are above the x-axis, it's not a guarantee that I will intersect the x-axis. That means what I need one value negative, one value positive. because if one value is negative, one value is positive, okay, I don't know on which interval, of course, but I'm just trying to show you how we can use this property. If I will get, let's say maybe for 1, if I will get for 1 negative value and for 2 positive value, okay, then it's obvious that I have to connect these 2 points. I have to, because function is continuous function. Connecting these 2 points, I am intersecting the 0, the x-axis. Okay, that means I do have that 0. That means one value must be negative, one value must be positive. Okay? That we can see both values for point A, both values are positive. That means that's not a guarantee. Okay? That means please remember that's what we're looking for. Let's check point B. Point B has an interval from 0 to 1. I need the value at 0 and I need the value at 1. Value at 0 is 3, value at 1 is 1 minus 3 minus 2 plus 3. It is negative. Oh, that means the option B is the correct one. Let me check. 1, negative, negative. Okay, works. That means this is positive number. This is negative. Okay, let me draw it. I know that I draw multiple graphs, but you can pause the video and get the graphs back. But, okay, from 0 to 1. Value for 0 is 3. And value for 1 is negative 1. My scale is a little bit. Okay, that means having 1 negative, 1 positive, I have to connect them. Either way, I don't even know, but definitely the point C, that is actually the 0, the x-intercept exists. Okay, that means B is the correct answer. I hope CD doesn't work. Okay, we can see that. That's how we can check. Probably if this will be me taking a test, I will still double check C and D. Okay. It doesn't cost lots of time, but I will check value at 1 and value at 2 because it's easy to make arithmetic mistake, even if we understand the concept. That means D is testing 2 and 3. Let's just double check. Value at 1, it's negative 1 because we did have, and value at 2 will be 8 minus 12 minus 4 plus 3. This is negative. That means this is negative and this is negative. Both negative values are not giving me this guarantee because both of them are below the x-axis. Okay, and let's check this one. Value at 2, it's negative. I don't even have to compute. And value at 3 is 27 minus, 9 times 3, 27, minus 6 plus 3, also negative. Okay, that means no guarantee. I really need one number above, one value, one number below. Okay? Either way. Okay, that means doesn't work, doesn't work, doesn't work. B is the correct answer. Okay, I hope we understand the intermediate value theorem. Okay, that's everything for chapter 1. Now, yes, we almost halfway through, but don't worry, I'm not gonna keep you another hour. No. We will speed up a little bit. That's what we have. Chapter 2 was derivative, and we do have a definition. We remember the limit definition. That means I wish to ask you the open-ended question and to state the definition and get the definition. But of course, we don't really have the option for the open-ended question. That means each question is multiple choice. That means I can show you how I can check if you know the definition. Okay, that we understand. I will not explain this. Limit as h goes to 0, f of a plus h minus f of a over h. Or derivative as a function. Instead of a, we have just x. F of x plus h minus f of x over h, if h goes to 0. That's derivative. Okay, and for example, I have a function 1 over x. We can see if function is 1 over x, find the formula for f prime of x. That means I might ask you, okay, like if, let's say, if this limit, or maybe, yeah, this one, or probably this one, yeah? If you will use the definition of the derivative, will this limit represent a derivative of function 1 over x? Okay? And we can see that's the definition, f of x plus h minus f of x over h. And then we have to evaluate for 1 over x instead of x plus h, instead of x, actually just the same function h. That means, yes, this limit represents the derivative of the function 1 over x. You can probably check, I think, week 2, self-assessment quiz and weekly quiz, because I did ask the same question that I'm going to ask you the same way I will ask you on the midterm. Okay? That means something like that, just to recognize. And it will be nice to simplify everything and get the derivative. That's the derivative. Okay, that's one of the questions that I will definitely ask for the definition. Okay, and then what we had in chapter 2, we have just the shortcuts for the derivative. We still have to understand the concept, but I think we do. Tangent line, slope of the tangent, but also we have to know how to compute the derivatives. That's when we have a power functions, we have trigonometric functions, we have root functions, we have lots of different functions. We do have a chain rule, which actually we will solve this question because this question contains a lot. Okay, we have a chain rule, and we do have implicit differentiation, I believe, and one of the application, quite big application, is the related rates. Okay? That means probably today I will not solve any related rates question. Okay, what I can do, I did make the video for you, but I will probably make additional one, really short one, just a few questions, the related rates question. Okay, just for you to show you one more time how we can solve it. But let's just finalize today the session with the derivatives. Okay, let me see what I have. Okay, I do. Oh, okay, we have quotient rule. Okay, let's solve a few questions. Let's look at this one. If the function f of x is defined as a tangent cube of 3 of x, find f prime at pi over 9. That means, first of all, we have to find a derivative, f of x, f prime of x. That means function f of x is defined as a tangent 3x to the power of 3, because we know that I can rewrite trigonometric powers of the trigonometric like that. That's mean what we have. We do have an inner function and outer function. Outer function is a power function, and inner is trigonometric. However, this trigonometric has even most inner function, 3x. That's mean let's differentiate. Quantity to the power of 3. Derivative of, like, let's say, I think I was using u at my session. U cube will be 3, okay, 3u squared, and follow the chain rule times u prime. And u, of course, is the entire quantity. That means I will not play these games anymore. Instead of u, I will put tangent 3x squared. Right? That means 3 times quantity tangent 3x squared times derivative of tangent. Who can tell me what's the derivative of tangent? Because I hope you didn't fall asleep after this whole intermediate value theorem. Derivative of tangent, secant square of x. I believe that's square, right? Secant square, but I can't just put x. I have to copy exactly the same angle that tangent had. And since this is additional thing, additional 3x, I have to multiply by the derivative of 3x. Okay, that's pretty much my derivative. 3 times tangent squared of 3x times derivative of tangent, secant square of 3x times derivative of 3x, 3. Okay, and let's see. 3 times 3 is 9. I can put this. Actually, I don't really have to simplify. I can just substitute maybe just this. I will write like that. And now a little bit of unit circle values. Let's substitute instead of x pi over 9. Pi over 9 times 3 is pi over 3 squared. 3 times pi over 9 again, pi over 3 squared. Okay, now tangent at pi over 3, tangent at 60 degrees. Do you know the values? You can go through sine over cosine if you don't feel comfortable, or if you know, you can say square root of 3. Now, secant. Do you know secant of pi over 3? Yes, thank you. That was a little bit easier. Yes, thank you. Just the reciprocal of cosine. 1/2, 2. Okay, who can do the arithmetic for me? And what's the final answer? 9 times 3 times 4. It is 108. I didn't check. I'm just believing Kishon. Which way we can do? 27 times 4 or maybe 12 times 9? I think I like 12 times 9. Of course, no calculators, right? 12 times 9, I think it's much, much faster to get 108. I mean, either way. Okay. Of course, the last line is not really a challenge, but make sure that you know your chain rule. Make sure that you know all of the trigonometric functions. You can check section 2.4, okay? All of the 6 function and of course its derivatives. Always thinking about the chain rule and the power rule, which is like u to the power of 3, 3u squared. Okay, now let's look at the product and the quotient rule. Quotient rule. Let's check if we remember the quotient rule. H of x equals to g of x over x squared minus 4. We do have some values. G at 3 is 2, g prime at 3 is 4. We have to find h prime at 3. That means function h is defined as a g over x squared minus 4, and we have to differentiate first. Quotient rule. Derivative of the top times denominator minus the top times, what's the derivative of the denominator? Who can tell me? Oh, thank you, just testing. 2x, really good. Okay, and then denominator squared. That means hopefully you remember the formula. And now it's just the arithmetic. Now, this is the important, the first step is important. Please do not make the mistake. And then we can just substitute 3. G prime at 3, 3 squared minus 4, G at 3, 2 times 3. 3 squared minus 4 and squared. G at 3 is 4, G prime at 3 is 4, 9 minus 4 is 5, this is 2 times 6. And this one is 9, 4, 5, 25. Oh, who can tell me the answer? 20 minus 12? It is the answer A, thank you. Yeah, somebody is really good with the arithmetic. Really good. Okay, but please note, whatever, of course, we have to get the final answer, but I'm really testing the first step. Okay? And I'm assuming that you're not going to make the mistake for your basic arithmetic. Okay, that's in quotient rule. And do I have product rule? Oh, okay, let's do this one. That's product rule and the chain rule. Find the slope of the tangent line. It's just a different way to ask you. Of the function x times sine of x squared at the point root pi 0. Of course, slope of the tangent is simply the derivative at the given point. Actually, I will use the red color. Okay, f prime of x. Please note is a product. That means I will use the product rule. Derivative of x is 1 times sine of x squared plus x. And now, what is derivative of sine x squared? Because I have to differentiate sine x squared. It's cosine x squared times 2x. Thank you, because times derivative of that inner function. Good. And again, I will not mess up this. I will just substitute, because slope actually is this, is the derivative at the given point. That means sine, if I will square root of pi, I will get pi. This will be square root of pi, cosine at pi, 2 root pi. Okay? Again, unit circle. Who can tell me sine of pi? Sine of pi, it's 0, thank you. Actually, 2 root pi times pi is, 2 root pi times another root pi is pi, but I need cosine at pi. What is cosine at pi? Cosine at pi is negative 1. That means the final answer is negative 2 pi. Okay. But again, of course, this one is maybe more challenge because it's the trigonometric values, but the product rule will be tested if you will do this. Okay, let's see what else important, because I don't want to keep the session long. As I said, I will provide for you the short video about the, just one more time, the related rates. I can skip this one, I can skip this one. I can skip this one. Okay, let's solve this question as a. I will skip. You okay with the? Okay. This will be the last question for today, okay? Because most of the rest of them is just the implicit differentiation, but I'm sure you know the implicit differentiation and related rates. Okay? Unless you want me to solve one of the related rates question. Okay, but yes, okay, I can solve one of them. Okay, let's solve this one, this question, and let's solve one related rates. Okay. Okay, that's what we have. We have a particle moving in the straight line with the position function s of t is equal to t cubed minus 60 squared plus 90 plus 1. And of course, t is the time greater than 0, measure in seconds, s is the position, the distance in feet. When is the particle moving in the negative direction? Okay, that means hopefully we remember the condition. Particle is moving, yes, in the negative direction. It's like changing, because moving means it's like a rate of change, right? It's rate of change of the distance with respect to time, which of course is the derivative. Or I can even say velocity, because since we move. And it's negative direction if this is negative. As simple as it is. If it's negative, the velocity is negative. That means let's find the first derivative. 3t squared minus 12t plus 9 must be less than 0. I have to solve quadratic inequality. Factor out 3t squared minus 4t plus 3. And let's factor out the quadratic expression, t and t, 3 and 1, minus and minus, because negative 4 and 3. Okay? That we can see t is 1 and t is 3, but that's my zeros. I still have to test it. Right? 1 and 3. Okay, but what I can do, I can test each sub-interval, or I can think about the velocity as a quadratic function. Can you see this is quadratic function? The graph of the quadratic function is parabola. Since the leading coefficient is positive, parabola is open up. And that's my zeros. Negative, positive, positive. Of course, we're only looking at positive because at 0. That means this function or this inequality is negative if t values are between 1 and 3. We can see that's the negative part. Oh, actually, I don't want to, I just need, okay, that's negative. That means between 1 and 3, it's negative direction. Okay, I can write t belongs to the interval from 1 to 3. Okay, really nice question. Okay, yeah, let's make sure, of course, positive direction will be positive part from 0 to 1, from 3 to infinity. Okay, and let me pick, I will skip the implicit differentiation, nice and easy. I have this one. Okay, let's maybe solve this one. Okay? Because what is the idea? We do have, for all of the related rates, if you listen to the video, you probably remember, whatever we have, whatever we're talking about, whatever label we have to remember each quantity is a function of time. That means when we differentiate, like let's say x, derivative of x will be dx dt. Derivative of y will be dy dt. Like derivative of r will be dr dt. Everything is changing unless some values are given. Yeah, like let's say this one, this box has a dimension 2 and 3. That we can see the width 2 and the length 3 is not changing. That means if something is not changing, of course, we will take it like it is. But if something is changing, like let's say that height is changing, then we can't say like, oh, height is like a value. No, height is changing. That means derivative of height will be dh dt. And since it's the related rates, we do have to like read the question. We have to get some connections between the given information, but also we have to differentiate because we need a relation between the rates of change. That's, let's see this question. The water pours into a fish tank at the rate 3 cubic feet per minute. That means the given information, I always like to write the given information is the rate of change of the volume with respect to time, it's 3 feet cubed per minute. Okay, dv dt, volume. How I recognize? Because it's cube. Yeah, that we can see that the rate of change, of course, volume is always cube. Now, how fast the water level rising, how fast is the water level rising if the base of the tank is a rectangle with the dimension 2 and 3. That means required information is dh dt. Okay. And this one is probably the linear relation that we don't have the moment, but when the length is 3 and the width is 2, it's fine. We can actually use this. Okay, that means we need a volume of this box, length, actually let me write this, length times width times height, but we can see the length is always 3, it's not changing, width is always 2, and the height is changing. That means the volume is defined as a 6h. Now I do have a relation between v and h, but I have to differentiate because I need the relation between the rates, related rates. Derivative of the volume is dv dt. Derivative of 6h is 6 times dh dt. Yes, as I said, every single label, every single quantity that is unknown, it's the function of time. Okay, now we can substitute all of the values. The rate of change of the volume is 3, 6, and we're looking for dh dt. That means the rate of change of the height will be 1/2, 3 divided by 6. And of course, feet per minute. Always copy the units. Okay. And that was actually nice and quick question. Yeah, we may have more challenge question, but I think that gave you the idea. Okay, that means please always remember, find the given information, find the required information, find the relation, nice and easy relation, and then differentiate. And then we can substitute everything what was given. Okay, does this make sense? I know that we're all afraid of the related rates, but I can promise if you will check the question on these slides and the question on my video from section 2.6, all of the questions that are on that, the related rates question, you will definitely get enough practice and you will be successful on this topic on your test. I hope we get a triangle. Okay. What about the cone? Do you remember the cone question? Yes, yes, okay. Make sure that you know the cone question. Okay. I think it's my question 7 or 8 on my video. Yes, kind of like, yes, Kishan, you, yes, yes. We have to read between the lines, right? Yes, that's me. Make sure that you know the cone question. Okay. But as I said, I will probably solve maybe 3 problems, 3 related rates problems, and I will put a short video for you. Okay, you can check the module 4, the week 4. Okay, and I will be still available. If you have any question, please post on the discussion. I will be more than happy to answer. Please check every single sample test. We have 4 of them. Print them like a blank test and try to solve it. Okay, please do it. And then you have the full solution to check against. Please, because this will be excellent, excellent practice. I don't like, do you know the dirty looks of your teachers? You can't really see me. Can you see me now? Where am I? I don't know if I can see myself. You can see me now. Okay, where are the sample tests? I don't like questions like that. Who can answer? No, I mean, it's also good, but you don't have to search the main website. I am providing everything for you. What week we have? Okay, who asked this question? Teja, I don't know if I'm pronouncing the name correctly. Teja or Teja? Teja? Okay, what week we have now? Okay, probably I'm pronouncing wrong anyway. Okay, let's answer this question. What week we have now? 4. Do we have modules? Do we have module 1, 2, 3, 4, 5, and so on? Module 4 is related to the week 4. Yes, as soon as Monday, as soon as we have Monday, you have to look at the new, maybe Tuesday, because Monday is still the due date for the quiz. You have to check every single folder, every single file in that module. Okay, that means everything what is related to the test. For you to be successful on that midterm, check everything what is in the module 4. Okay, week 4. Okay, that's what I put. I copy all of the, I downloaded all of the sample tests from the main website. You don't have to search on the main website. I mean, it's easy to find, but it's easier to look at the canvas. Because that's online class. That's me. I'm trying to provide everything for you. Okay, every single week, check the modules. Okay, and always look at the front page. Some information you can always find. But all of the sample tests and in the week 4 modules. Okay. Okay, and the full solution is also provided for you. Okay. Any other technical question? That means, I mean, you can still ask, but work on your limits, work on all of these questions that you saw today. You can even rewatch this video again and check 4 sample tests, okay, in the module 4. Okay. Okay. Do you have some questions? If not, we can finish the session because it's quite late, but thank you. Thank you for joining me. I'm really appreciate that. I'm really respecting that because it's quite late. Yes, I see few names. Yeah, I mean, not really. It's good. Yes, good participation. I know that some students, most of the students are watching the videos, which is also good. Okay, and I will be still available if you would like to meet with me, like office hours. I can meet with you like in this classroom, and I can also use the whiteboard and answer your questions if you like, if you feel comfortable this way. even could be like one-to-one. That's what I do sometimes with the students. Okay? Because of course we don't really have a contact. Yeah, we do have actually, but it's not like a normal residential class. Okay, that means I will let you go. Please practice a lot. Put any question, email me if you have questions. Is there a time limit for the exam? Of course it is. Check the main website. I mean, no, check the front page. You will see the exam info and you will see this. It's 90 minutes. Yes, thank you. Thank you. Again, yes, I know, you asking we all stress about the first midterm, but don't worry. Yes, the limit is 90 minutes. Okay? If you will take a sample test and the practice test, you will get the taste of your test. Oh no, the office hours are on by appointment. If you will email me that you would like to meet with me, of course I have to check my calendar, but I'm quite open. I can meet with you. That means sometimes even depends when are my office hours, depends on time zone. Okay, that means please email me with some questions and I can always open Zoom and we can always hop into the Zoom room and you can see me and I can explain the question, the answer. Okay, but please again, one more time, do all of the sample tests, okay, all of them. Print the blank one, set up that clock, 90 minutes, and just the desk, the test, and the pencil, and try to solve it. And then you will see if you can solve all of them, okay?